valuing these things highly enough in the literature, so we're not extracting people's views about how much they would pay to avoid these and things like that, or they're just not dominating, and it may not be appropriate to actually try to quantify these things in this way. So that's two of the things that came out of this. From the environmental impact side, the results are sort of mixed, and so it depends on which type of pollutant you're most interested in, that it will influence the choice that you make. So sulfur dioxide emissions, the highest is the coal by wire, and that's because even though it's a low sulfur coal, generating that additional electricity that's required to compensate for the line losses actually emits more sulfur dioxide than the diesel that's used in the rail system, and that's because there are ultra low sulfur diesel requirements associated with the diesel that's consumed. So you get higher emissions from that. The CO and the NO2, that's dominated by the coal by rail, because there are not restrictions on the CO and the NOx that get emitted from the rail system, there are very stringent requirements associated with the NOx. The CO implies that there's incomplete combustion, and so that is minimized in the power plant because they want to maximize the power output. The volatile organic carbon is also higher for the rail system and for the pipeline system. The particulate matter is pretty close for the coal by wire versus coal by rail. And then greenhouse gas emissions, the highest is the coal by wire. So the additional coal that you're generating is actually producing more greenhouse gas emissions than the diesel system. And so you're actually using the diesel more efficiently in the transport than burning more coal to go through the transmission line. Any comments on that? So the answer basically is that it depends, right? That it depends on what you care about and how you look at the system. This again is looking if you had to build the transmission, the rail system from scratch, and so I did do sensitivity analysis to vary that. But is anything surprising about this, or is this sort of what you had in mind? Yep.
Sorry, I just didn't quite catch. You were saying that because the diesel is cleaner, the greenhouse gas effect of using a locomotive system is less than if you were to make a transmission line?
Yeah, so this is looking at the trade-off between using the rail system that requires the diesel to transport the coal versus using the transmission line, which is using the coal itself as additional electricity generation that actually will provide the energy at the end use. And we were quite surprised when we looked at this that the rail system had become as efficient as it was. That using the diesel in the locomotives was actually a really efficient way to actually transport that electricity, or that energy from the coal. Yeah, so that was quite surprising. Just looking at this, you can see this is the greenhouse gas emissions with each of them. So the rail system is at the 0.25 million tons of emissions, and the coal by wire is more than double that in terms of the emissions associated with that, and that's because you have to generate more or use more energy to actually to transport that coal energy by wire than you do by rail. But then if you look at the cost difference, so this is $15 million spent on fuel in the rail system versus $2 million spent on the coal. So again, it's higher in emissions to actually burn the coal, but it is a cheaper option to do that. So that's again where you sort of get that conflict between the sort of economic results and the environmental impact. So this is just thinking about the sort of impacts that you can look at and how you can actually go about doing that in the life cycle area. This is, there's lots of different ways that you can try to translate those tons of SO2 that get emitted into an actual impact, right? And so the one way that I talked about was actually just trying to value this. So this is one of the options that you can do. You can sort of categorize, you can sort of, there are some efforts that try to develop one index so that you can actually collapse all the different environmental impacts into one number. So that for the rail it's a 12, and for the transmission it's a 14. And that can try to, you can try to simplify it, but by doing that you sort of miss the details. And if you really care about local air quality effects versus climate impacts, then you sort of miss those details when you do that, and so it's a little bit dangerous to do that. Yeah.
And do you then using that? Do you ever just put a weighting scale depending on who's looking at the data?
Yes, and so a lot of times that happens so that you actually do weighting. the guidelines that are put out by the ISO 14040 series actually say that you should not do that if you're going to take the results to the public. And one of the issues with that is that deciding on how you weight these different things is a value judgment. And so absolutely you shouldn't be doing it as an analyst, because that's not your job, is to not put your own personal views about these things onto it. What can happen though if you're using it for an internal exercise where you have a decision maker that you can elicit their values and say, translate those values into the weightings that you might use, and say, because you care more about the sulfur dioxide emissions and the local impacts than you do the greenhouse gas emissions, these are the results and this is how things look. But it is a very slippery slope, and it's, the transparency associated with it is key. So if you are going to do that, you want to be very explicit about these results only apply for this particular set of values, and you might also want to test it against other types of values that you could be looking at.
And does this eventually go, say for example, into like a net present value, so that you would, like I said, you put a valuation on it so that you're putting it in and comparing the projects, which is where the weighting would certainly come out.
Yeah, so that's sort of basically what I did, right? So I annualized all the costs, so I'm putting it on a sort of dollar per year sort of basis. So behind all of that is the amortization of the capital and all of that kind of thing. And then what I did was actually valued the environmental impacts and tried to internalize them. So it does come out to a dollar value comparison. I'm just going to quickly go through this. So this was where I got the actual values to actually do the exercise that I had done. So I took all the emissions in terms of the mass of the different species that were emitted, and I went to this literature. This was a summary paper that tried to take into account all the external costs that had been calculated for each of these different emissions. So for NOx emissions, the literature was sort of showing that you had a minimum of $220 all the way up to $9,500 per ton of NOx emissions that could be emitted. And again, this goes to the literature, both in terms of the health side, so the EPA, the U.S. Environmental Protection Agency, has tried to get involved in some of this, but a lot of it comes from the medical community, where they're trying to look at the costs and benefits of different types of procedures and things like that. They've come up with a sort of value of a statistical life, and so at this time it was $5.3 million for a typical life, and so every time you have a death, you would assign $5.3 million to that death. And it goes to the health community in terms of how many asthma cases would they see in a hospital based on this concentration of emissions that you would have, all of those kind of things. It also goes to a literature that looks at things like willingness to pay. So they go and conduct exercises to say, how much would you pay to reduce the NOx emissions by a certain amount? And use that to try and elicit the values that people have about these types of emissions. So it combines both of those literature, and you end up with these values. At the time, so this was actually published in 2000, so it's a little bit dated now, but the greenhouse gas emissions were valued between $2 and $23 per ton. A lot of the technologies and mitigation options we're looking at right now are in the hundreds of dollars per ton. And so I think that if you did this exercise again today, it would be very different than where we're at, but I think Bob Savage, who's going to talk later, will talk about the Alberta policies and that we're at about a $15 per ton. So this isn't actually all that different from that. But one of the other examples is the particulate matter. It ranges from 950 up to 16,000